In the vast, inky depths of our planet's oceans, where sunlight fears to tread and time seems to stand still, lurk creatures that defy our understanding. For millions of years, scientists believed one of Earth's most ancient inhabitants, a creature with lobed fins and an armored body, had vanished into the annals of prehistory. We called it the coelacanth, a fish thought to have gone extinct alongside the dinosaurs, some 66 million years ago. Its fossilized remains told tales of a bygone era, an age when fish first began to crawl onto land, hinting at our own distant origins. But then, on a fateful day in 1938, a small fishing trawler off the coast of South Africa hauled up something that would rewrite textbooks and ignite one of marine biology's most enduring mysteries. Marjorie Courtney Latimer, a museum curator, received a call about a strange, blue fish, unlike anything she had ever seen. Its bizarre, limb-like fins and unique scales immediately caught her eye, sparking a profound sense of recognition. This wasn't just a new species, it was a ghost, a living relic from an epoch long past, alive and swimming in the modern ocean. The coelacanth, a creature thought extinct for 66 million years, was back. How could such a large, distinctive animal escape detection for so long? Where had it been hiding, and what secrets did its improbable survival hold? This discovery wasn't just a scientific anomaly, it was a profound challenge to our understanding of evolution, deep-sea ecosystems, and the very concept of extinction. The coelacanth became a symbol, not just of survival, but of the vast, unexplored unknowns that still lie beneath the waves. The term living fossil quickly became synonymous with the coelacanth, and for good reason. Its skeletal structure, fin arrangement, and even its internal organs bear striking resemblance to its fossilized ancestors from the Devonian period, over 360 million years ago. Imagine, a creature that has navigated the tumultuous waters of evolutionary history for hundreds of millions of years, surviving ice ages, mass extinctions, and continental shifts, seemingly unchanged. This remarkable stasis, this apparent resistance to the forces of natural selection, is itself a profound mystery. How does a species maintain such morphological conservatism over such immense timescales? One dominant theory suggests the coelacanth found an evolutionary niche so stable, so perfectly suited to its environment, that there was little selective pressure for significant change. This niche, we now know, is the deep sea. The abyssal plains and rocky slopes below 100 meters offer environments that are remarkably consistent in temperature, light, and predation pressure. For a creature adapted to these conditions, the world above may have changed dramatically, but its own deep water home remained a timeless refuge. Another theory posits that its slow metabolism and long lifespan contribute to its stasis. Evolution often thrives on rapid generation turnover, allowing mutations to quickly spread. If a creature lives for decades and reproduces infrequently, the pace of evolutionary change would naturally slow down. But is a stable environment and slow life history enough to explain millions of years of near-perfect preservation? Or is there something more fundamental about the coelacanth's genetic makeup, a kind of evolutionary inertia, that has kept it locked in time? The paradox of the living fossil challenges our assumptions about how evolution works, prompting us to consider the nuances of adaptation and environmental influence. To understand the coelacanth's improbable survival, we must delve into its unique biology, a testament to deep-sea adaptation. Unlike most fish, coelacanth possess 8 fleshy, lobed fins, which move in a coordinated, almost limb-like fashion, reminiscent of a tetrapod walking. This unique locomotion allows it to drift lazily with currents, conserving energy, or to slowly walk along the seafloor. Its swim bladder, typically gas-filled in other fish to control buoyancy, is instead filled with oil, a more effective and stable buoyancy control mechanism in the immense pressures of the deep. Its eyes are large and specialized, featuring a reflective tapetum lucidum behind the retina, enabling it to maximize the capture of what little light penetrates its murky habitat. But perhaps one of the most intriguing adaptations is its electrosensory system, a rostral organ in its snout that can detect faint electrical fields, likely used to locate prey in the dark, much like sharks. These aren't just random traits, they are a finely tuned suite of tools for navigating and surviving in an environment that is both unforgiving and stable. Yet, even within these adaptations, anomalies persist. Why maintain such an ancient, heavy skeletal structure when lighter, more modern forms exist? Why the incredibly slow growth rate, reaching sexual maturity only after many decades, when faster reproduction might offer an evolutionary advantage? Scientists continue to unravel the precise functions of these ancient features, speculating on their dual roles in both deep-sea survival and perhaps, in a distant past, even in the transition from water to land. The coelacanth isn't just surviving, it's thriving in its own peculiar way, a testament to the power of ancient design. Despite decades of research since its rediscovery, much of the coelacanth's life remains shrouded in mystery. We know it prefers specific deep-sea habitats, primarily lava caves and rocky overhangs between 100 and 400 meters, often near volcanic islands. Here, they spend their days in communal groupings, seemingly resting, before venturing out at night to hunt for smaller fish and cephalopods. But the real enigma lies in their reproduction. Coelacanth are ovoviviparous, meaning they give birth to live young after eggs hatch internally. This is rare among fish. What's even more astonishing is the gestation period. Scientists estimate it could last up to 5 years, potentially the longest of any vertebrate. Imagine a 5-year pregnancy for a fish. This incredibly slow reproductive cycle, combined with what appears to be a small population size, raises serious questions about their vulnerability. Where do the young go after birth? No juvenile coelacanth have ever been observed in their natural habitat, leading to speculation that they might inhabit even deeper, more inaccessible nurseries. Are they solitary during their early years, or do they have their own specific, undiscovered hiding places? This lack of observation makes it incredibly difficult to assess population dynamics, understand recruitment rates, or even determine the full extent of their range. Each birth, each successful rearing of young, becomes a monumental event in the coelacanth world, placing immense evolutionary pressure on the species. The coelacanth's secret life is a delicate dance between extreme longevity and incredibly slow reproduction, a strategy that has worked for millions of years, but one that leaves it incredibly fragile in the face of modern challenges. Even a creature that has cheated extinction for millions of years is not immune to modern threats. Deep-sea fishing, particularly the expansion of gillnet fisheries into deeper waters, poses a significant danger. Coelacanth, often caught as bycatch, are highly susceptible due to their slow reproduction and limited populations. Habitat destruction from deep-sea mining exploration, though not yet widespread in their known habitats, represents another potential future threat. Conservation efforts are underway, with both species of coelacanth, Latimeria columni and Latimeria menedoensis, listed as critically endangered or vulnerable. But how can we effectively conserve a species whose true population numbers, migratory patterns, and full life cycle remain largely unknown? The fundamental questions persist: how many coelacanth are there? Do they migrate vast distances, or are populations isolated? Is their distribution truly limited to a few specific regions, or are there undiscovered populations in other deep-sea canyons and caves? Genetic studies have revealed surprising diversity within localized populations, suggesting some level of genetic exchange, but the mechanisms remain unclear. And what about the mystery of their sensory capabilities beyond their eyes and rostral organ? Do they communicate using sound, or chemical signals, in the perpetual darkness? Each piece of evidence we uncover seems to generate 2 new questions, further deepening the enigma. The coelacanth, a living relic, forces us to confront the limitations of our knowledge, reminding us that even after nearly a century since its rediscovery, its world remains largely a mystery, a shadow in the deep. The story of the coelacanth is more than just the tale of a fish that refused to die, it is a profound testament to the resilience of life and the unfathomable depths of our oceans. It is a living, breathing paradox that challenges our understanding of evolution, adaptation, and extinction. Its survival, spanning hundreds of millions of years, offers a unique window into Earth's ancient past, providing clues not only about the origins of vertebrates but also about the stability of deep-sea environments as refugia for ancient lineages. Yet, the coelacanth remains largely an enigma. Its true population size, its full life cycle, its exact breeding grounds, and the full extent of its deep-sea kingdom are still largely unknown. We have glimpsed its ancient form, observed its peculiar movements, and theorized about its adaptations, but the deeper secrets of its longevity and its delicate existence continue to elude us. What other, living fossils, might be hiding in the vast, unexplored reaches of our planet? The coelacanth reminds us that extinction is not always final, that life finds a way, and that our maps of the natural world are far from complete. As we push the boundaries of deep-sea exploration and face the growing challenges of environmental change, the coelacanth stands as a silent sentinel, urging us to protect these vulnerable, ancient ecosystems. Its mystery is an invitation, a call to continue exploring, to continue questioning, and to foster a deeper respect for the hidden wonders that still dwell in the deepest parts of our blue planet. What do you think is the biggest secret the coelacanth still holds? Share your thoughts in the comments below, and don't forget to like this video and subscribe to Deep Ocean Mysteries for more journeys into the unknown.